My name is Salil Pradhan, and I am product manager with MySQL Heatwave team. Today I am going to talk about building MySQL applications with REST, Apex, Jupyter, and Zeppelin notebooks. According to well-known and independent survey from Stack Overflow and JetBrains, MySQL has been number one choice for developers for a long time. MySQL Heatwave is the only MySQL cloud service with a built-in high-performance in-memory query accelerator. It increases MySQL performance by orders of magnitude for analytics and mixed workloads without any changes to current applications. With MySQL Heatwave ML, developers and data analysts can build, train, deploy, and explain machine learning models in MySQL Heatwave without moving data to a separate machine learning service. Thus, a user can do OLTP, OLAP, and ML queries without moving the data to a different data store, which means user does not have to do expensive and complex ETL, and all the queries always run on the most recent data. Heatwave ML allows a user to perform machine learning on data stored in MySQL database. It provides a fully managed environment to build fast and accurate machine learning models. It supports true in-database machine learning, where neither data nor model leaves database, resulting in a secure and easy to manage machine learning environment. Explainability support in Heatwave ML enables users to identify the most important model features, and it is model agnostic, which means any model created with Heatwave ML can be explained. It provides database user-friendly interface so that a user does not need to be a machine learning expert to build sophisticated ML models. MySQL Heatwave ML performance scales with number of Heatwave nodes. It is highly cost efficient compared to competing products, and a Heatwave customer does not need to pay any additional charges for using Heatwave ML. It leverages Heatwave cluster for distributed machine learning. Here is a typical deployment architecture where MySQL data service node exposes a private endpoint and is accessed using development tools running in Oracle Cloud Infrastructure, such as notebooks in OCI Data Science, Apex, and Oracle Analytics Cloud. User can also create a SSH tunnel to compute instance and access MySQL Heatwave from outside the OCI infrastructure. With MySQL Heatwave ML, user does not have to move the data outside database and use third-party libraries to build a model. Instead, data and model always remain in the database, which provides secure environment to your data and model. You do not need to do complex ETL to move data out of the database. When a data scientist creates a ML model, user trains data. First, training data is collected and right data features are identified. Data is pre-processed by doing data imputation, cleansing, standardization, and normalization. Appropriate algorithm is selected out of many possible algorithms, and hyperparameter values are identified. These tend to become a time-consuming and iterative process. With Heatwave ML, developer focuses on identifying the business problem and collecting the training data. The ML train routine handles all the ML pipeline steps that typically needs a data scientist. The training phase also creates model explanations. Once the model is created, developers can compute model score using ML score routine, and if score needs further improvement, developer can look at explainability results based on which additional features can be explored and model can be recreated until an acceptable score is achieved. In this section, we are going to discuss how to build MySQL application with notebook environments such as Jupyter and Apache Zeppelin. In last few years, notebook environments have gained enormous community support, mainly from the data science community. This is due to the support for various languages and frameworks that notebook environments offer. It is also because notebooks offer a free, open source, and interactive IDE, which can also be used as a presentation tool. Jupyter and Apache Zeppelin are two popular notebook environments. You can use them with MySQL HeatWave. While using notebook environment with MySQL HeatWave, user can use Python and connect to HeatWave. User can visualize and explore data and determine model features. User can invoke routines to train model, infer, score, and explain from within the notebook. In this demo, user is going to create a model based on census data from UCI machine learning repository. The goal is to predict if an individual makes less than 50K or greater than 50K based on various features. User first establishes the connectivity with MySQL HeatWave. This is done using the Python code you are seeing in the demo. Once the connectivity is established, user wants to see key features in the training data. This is achieved through the describe statement. As the next step, user wants to do some exploratory analysis, and user uses the visualization abilities of Python to do so. In this case, users have charted how many people are making less than 50K and how many are making more than 50K. Similarly, user can do additional exploratory analysis and visualization for identifying the significant features of the data. Once the training data is ready, user will call ML train function with the parameters such as training data, prediction variable, the task type, as well as model handle. Once the training is completed, user should load the model using ML model load function. As the next step, user computes the score of the model to find out the model quality. Model explanations are created when user runs ML train command. These explanations are stored in user schema in the table model catalog. User can access the model catalog using the query shown in the demo. User can visualize the model explanations to find out the important features of the model. As you can see, capital gain and education number are the most important attributes for this model. User can also run prediction explanations, which are explanations on a specific row of the data to find out which are the important attributes for that specific row. User can find out the prediction for an individual to see if the individual makes less than 50K or more than 50K. And user can use ML predict row function for that. In the end, user can compute the confusion matrix and render it to show the classification model quality. Next, we are going to build MySQL application using Apex. Apex is Oracle's strategic low-code application development platform that enables you to build scalable, secure enterprise apps with world-class features that can be deployed anywhere. Oracle Apex enables a developer to design, develop, and deploy beautiful, responsive, database-driven applications. It allows users to quickly build reports, forms, charts, calendars, etc. on top of the data in your database. IT developers and citizen developers who know a little SQL can readily build the applications. Starting Apex 22.1, you can use Apex to build applications using data stored in MySQL database. It uses Oracle REST data service to talk with MySQL database service. In this demo, we are going to show how to build simple data dashboards using flight data stored in MySQL database service. User creates a new application. And creates the dashboard by selecting the dashboard layout. Now user starts defining various regions of the dashboard by providing details such as the location of the data, query to access the data, and the other parameters such as label and value, as well as the type of the chart user wants to show in the dashboard. User repeats this process for all the three regions that we have in this dashboard. As you can see, user is able to define various attributes without any coding. And now your dashboard is ready. User enters the credentials to access this dashboard. In a matter of few minutes, user was able to create a dashboard that shows various details about the flight. User can hover over to find more details of each of the pie in this pie chart, as well as details of the bar chart in terms of average ticket price and the wind speed by time. In this section, we are going to see how to build MySQL applications using Oracle Analytics Cloud. Oracle Analytics Cloud is a scalable and secure public cloud service that provides full set of capabilities to explore your data and perform collaborative analytics. Oracle Analytics Cloud enables you to connect to MySQL database to explore and visualize data stored in MySQL database. It offers optimized native connection to MySQL, high performance interactive analytics, supports connectivity to private MySQL service, and allows MySQL users to take full advantage of all capabilities of that OAC offers. In this demo, we will see how Oracle Analytics Cloud can be used to analyze data stored in MySQL database service to derive insights. User configures connection to MySQL data source and defines data layer using which user can create interactive visualization. User searches for the sales by product category report. As you can see, there are customer segments such as consumer, corporate, home office, and small businesses. And then there are products such as technology, office supplies, and furniture. User can view language narrative to find out what is being shown using standard text. User can also find out various insights shown by this report. User may want to drill down into more details of a specific insight. As a next step, user wants to find out sales over time. So user selects sales and month and drags them on the canvas. As you can see, user can see the sales trend over time. All this data is coming through MySQL database and being rendered here using Oracle Analytics Cloud. User can also forecast based on this data the sales trend going forward. User can drill down in a specific year and see more details of the sales trend as well as the generated forecast.